This is Precalculus Practice Quiz 3.4. Jumping straight into number 1, we have a exponent with a variable. We need to untrap this exponent, rescue Rapunzel. The only way to bring Rapunzel down, to bring this power down, is to use a logarithm. We're going to take the logarithm both sides. I'm going to get log. I'll choose the base in a sec, and I'm just going to rewrite that and take the log of this side as well. Ooh, give us some room for the base over here. And let's write the original problem. It was a 66, and it was a 10 to the power of n minus 1. What base do we want to choose? You always choose the base of the exponential part of the function. So this is the exponential part. That's just a constant. So here's our base 10. This should also be a 10 down here. So I'm going to choose a base 10. If I do a base 10 on the left, I do a base 10 on the right, and I'm ready to go. I'm just going to go ahead and do the shortcut because we've been practicing this for a while. Things that cancel. You cancel, you cancel, you cancel, leave me with an n minus 1. On the right-hand side, we still have that log of 66. So this is going to be log, and I don't have to do base 10 because the default base is base 10. So I'm just going to write log of 66. From here, I'm going to add 1 to both sides. So I'm going to say, ooh, I have new colors now. So plus 1, and I now have n is equal to log of 66. And then after that, plus 1. And that is going to be approximately equal to, I should pull up my calculator. And where is my calculator? There we go. All right, now I have my split screen so I can type this stuff in. I have a log of 66, and then I'm going to add 1 to it. And I get 2.8, and then how many are we running to the nearest 10,000? So 4 decimal places, which makes sense because we're dealing with logarithms. Whenever you deal with logarithms, you need a lot more digits of accuracy because they compress things so much. 2.819, and then this number might get rounded. 5 does not get rounded up, it stays a 5. Let's go ahead and check our answer. 2.8195. 2.8195. All right, we got it. All right, how do we do number 2? In number 2, we need to get this exponential by itself, which means we need to get rid of that 7. Notice that the 7 is being multiplied, so we're going to divide both sides by that leading coefficient, that's 7. And when we do that, things that cancel out, you're gone, and I'm left with just 17 to the power of negative 2m, and this is going to be equal to this fraction 1/7. All right, from here, it is time to take the log of both sides. It's time to free Rapunzel, free this exponent to go down here. So I'm going to take the logarithm of both sides. I'm going to take the log of this side and make it equal to the log of this side. What was originally in here, we had a 1/7 over here on the right and a 17 to the power of negative 2m on the left. We get to choose any base that we want, and again, we're going to be using this base of 17. So I'm going to write here log base 17 and log base 17. When I do that, things are going to start canceling out. Things that cancel, we cancel you, and you, leaving us with a negative 2m on the left, and on the right side, we have that thing, that log base 17 of 1/7. However, this calculator over here on the left does not have a log base 17. We need to do the change of base formula. The way that we do that is we write, I want to do this in pen. Let's use orange, yeah. Oh wait, I'm still in green. So I'm going to do log of the top, or log of the inside, divided by log of the base, log of 17. And I don't need parentheses there, but I can write it just to be pedantic. And then we're almost done. The only thing left to do now is we need to, is this going to look too similar? That looks like the same color to me. So I'm going to go back over here to red and say I'm going to now divide that side by negative 2m, sorry, by negative 2, and divide this side by negative 2, which is the equivalent of just putting the negative 2 down here. And then things are going to start canceling out for us. You're gone, the negative sign is also gone, meaning we have m by itself, and it's equal to all of that. I'm going to go ahead and just say this is approximately equal to, typing this into the calculator, we have a log of 1/7, and that's all going to be divided by a negative 2, and I have another logarithm of 17. And I get about 0.343. This next number needs to be rounded. 4 does not need to be rounded, actually, because it's followed by a 1, so I'm just going to say 3434. And let's go ahead and box that. Let's see, 3434 on the back, 3434 on the back. Excellent, we're doing pretty well. Let's do these next problems. I assume that we don't need to use the calculator. We'll come back and use the calculator if we need to. I like having it full screen, though. It's much easier for me. All right, in number 4, we have log base 3 of 8. negative 8x is equal to 2. We need to undo this logarithm because this is technically inside the logarithm. How do I undo u? And the only answer to that is exponentiation. So here's exponentiation. You're going to say, I'm going to choose this base again, so base 3. 3 to the power of all of that log base 3 of negative 8x, and that's going to be equal to, and then again I have a 3 to the power of 2. I put both of them up on the exponent and a 3 for both bases. That's called exponentiation. From there, that will cancel out the logarithm. I now say cancel, 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 leaving me with a negative 8x on the left, and on the right I have 9, because 3 to the power of 2 is 9. And from there, I'm going to divide both sides by negative 8. So divide by negative 8, divide by negative 8, and I'll say x here is equal to negative 9/8 for my final answer, which I'll box and check our work. Negative 9/8 for number 4. Negative 9/8 for number 4. Did I miss a problem? Oh my goodness, I missed number 3. My bad, guys. I totally overlooked that. Let's go back to number 3. I was wondering why I had one answer that wasn't circled. All right, this is, the much harder question out of the first 3. How do we do this? Well, I'm looking at this 9. It's not technically part of this exponential function, so I need to get rid of that 9. 9 is being multiplied by that e, so I'm going to undo that multiplication with division. So divide by 9, and I'm now left with just e to the negative 2r minus 1 is equal to 66 over 9, which I guess it could be reduced. Let's go ahead and do that. Divide the top and bottom here by 3, divide by 3, and this is going to turn into 22 over 3, and I can't get any farther than that. I'll just leave it like that. So I was going to say 22 over 3. Excellent. Well, now it is time to untrap our exponent. So to do that, I'm going to take a logarithm to bring you down. And what logarithm base should we use? We should use a base of this base right here, base e. So I'm going to say log base e of all of this inside is equal to log base e of all of this inside. On the right, we have 22/3. On the left, we have e to the negative 2r minus 1. And as I said before, these are going to cancel out. So cancel, cancel, cancel. And I'm left with negative 2r minus 1. And that's going to be equal to, and okay, so log base e is also known as the natural logarithm. So I'm going to say natural logarithm, or ln, of 22 over 3. And then from there, I'm just going to solve for r. Right now, I need to get rid of that minus 1 by doing a plus 1 to both sides. So plus 1, and I'm now left with negative 2r is equal to natural log of 22/3, and then plus 1. And then from there, we need to divide by negative 2, divide all of that by negative 2, and that is approximately equal to, I have to get the calculator again. Shouldn't have done split screen or full screen quite yet. I guess the calculator wants to be on the right. Oops, that's a graphing calculator. Nope, try again. I want to split to scientific. So what are we going to have here? I need to type in natural log, so ln, and then I'm going to have this fraction 22 divided by 3. 3, please. Oh, gosh, there we go. 22 divided by 3, and then I'm going to do plus 1, and then if I end some parentheses right here, it'll keep everything in the numerator. So I'm going to go ahead and say function, do I have parentheses? Oh, there they are. Put them in parentheses, just end the parentheses, and then I'll say divided by, so it keeps it all in the numerator, and divide by negative 2. And I get, let's give myself some room to write, negative 1.496, and then that 2 does not get rounded up because it's followed by a 1, and there's my answer that I hope is correct. Let's see, negative 1.4962, negative 1.4962, we got it right. All right, now I'm going to put the calculator away. All these look like fractions. I'm just looking at the answers. None of them look like we need a calculator anymore. All right, now we're on to number 5. And from here, again, we're trying to isolate this logarithm. So this 4, we need to get rid of. 4 is being multiplied by that logarithm. So we're going to take the inverse operation and divide by 4. Divide by 4. And who's gone? You're gone, you're gone, leaving me with just a log base 2 of m plus 8, and that's going to be equal to negative 1. So far, so good. Now it's time for the exponentiation, aka the inverse operation of a logarithm. So I'm going to say, and this is me kind of taking a little bit of a shortcut, I'm going to say 2 to the power of all of that is equal to 2 to the power of negative 1. So I'm going to move the negative 1 and make that really the power, put the equal to sign down here, and there's my new equation. So from here, a lot of things are going to cancel out. You're gone, you're gone, you're gone, and I'm left with m plus 8, and that's going to be equal to 2 to the negative 1 is the same thing as 1/2, or 1 over 2 to the power of positive 1. From here, I'm going to subtract 8. So very simply, minus 8, and I now say m is equal to 1/2 minus 8, but instead of 8, I'm going to say minus 16. Ooh, I don't know what I'm writing there. Minus 16 over 2, because I want to have common denominators down here, so they both are divided by 2. Essentially, I had 8 over 1, I multiplied by 2, so I got 2 in the bottom, 16 in the top, 2 in the bottom, 16 in the top, right? And I'm going to subtract the tops. 1 minus 16 is 15, so this is going to be negative 15, and the bottom stays the same, negative 15 halves. I think that's the right answer. Let's go ahead and check. Number 5, negative 15 halves. Number 5, negative 15 halves. Pretty good so far. All right, number 6. Oh my goodness, look at all the things happening to the logarithm. You are the logarithm, you are not. We're going to get rid of you negative 8. I'm going to undo a negative 8 by adding 8 to both sides. And, ooh, the right side is going to look really nice there. It's going to cancel out. So I'm going to be left with a log base 5 of negative 3m plus 9, and that's going to be equal to 0. Okay, time for the exponentiation. So what base do we choose? We choose u, Pikachu. No, you choose u5, so I'm going to say 5, and 5, move things around a little bit with our exponentiation. You're at power of 0, you're the equal to sign in between. There we go, there's the exponentiation, and then things are going to cross off. Cross, 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 and we're left with negative 3m plus 9 is equal to, all right, what is 5 to the power of 0? Well, anything to the power of 0, other than 0, is going to be 1. And then I solve. So from here, I'm going to subtract 9, and I get negative 3m is equal to negative 8. And then from here, I'm going to divide by negative 3, divide by negative 3, and I get m by itself is equal to, okay, careful, negative divided by negative is a positive, so it's going to be a positive 8/3 for our final answer. Let's check. 8/3 for number 6. 8/3 for number 6. We're on a roll. All right, number 7. Ooh, I've got some natural logarithms, and I've got two of them on one side. How dare they? Well, I guess, how dare Mr. Sindel? That's me. All right, so I need to get this into one logarithm, and then I can exponentiate to undo it. So the way that we combine the logarithms from our, I don't know, it was like 3 or 4 lessons ago, is whenever we subtract the outsides, we divide the insides. So I'm going to rewrite the same natural logarithm, ln. It has the same base e, right? And then the insides are now going to be x divided by 6. It's going to be equal to 2. That 2 on the right-hand side hasn't changed. We only combined logarithms on the left. From here, now it's time to undo this logarithm. The inverse operation of a logarithm is exponentiation with that base. And because the base isn't super clear, I'm going to go ahead and change logarithm. I'm going to say log base e, so that everyone remembers log base e is the same thing as a natural logarithm. And then that means I'm going to do exponentiation with an e, and then I'm going to move things around so it looks a little bit better. That's e to the power of 2, and equal to sign goes right there. And my exponentiation is complete. Let's simplify, cross, cross, cross. I have an x divided by 6, and that's going to be equal to e squared. Right now I need to get x by itself. The way that I do that is undo division by 6, which means we multiply this side by 6 and multiply this side by 6. When we do that, we're going to go ahead and cross, cross, leaving me with an x on the left-hand side and a 6e squared on the right-hand side. 6e squared for number 7. 6e squared for number 7. All right. 2 more problems and we're out of here. Let's go. All right, so again, 2 logarithms, we need to combine them. Do I ever? Oh my god, I made them all minus signs again. It's very similar to the homework. What I need to do is change one of these to a plus sign. Be ready for a plus sign on the actual quiz. A plus sign on the outside means multiply the insides, but because we have a minus sign on the outside, we are going to be dividing the insides. So let's go ahead and simplify this to 1 logarithm. So I have log, again, you have to set the same base. If these were different bases, this trick would not work. But since it is the same base, I'm going to copy down the 4 from both of those bases. And on the inside, I have x plus 5, and I'm going to divide that by the other one, which is x. Okay, right-hand side hasn't changed. It's still 2. Now it's time for the exponentiation, and that's going to be, you're going to choose this same base of 4. So 4 to the power of all that is equal to 4 to the power of 2. I'm just going to, quickly move down the equal to sign so it looks kind of nice. And then from here, we're going to cancel some things out. 4 log and base 4 are all gone, leaving me with an x plus 5 divided by x, and that's going to be equal to 4 squared, which is 16. All right, now it's time to, I guess you just kind of cross multiply, right? You think, okay, this is divided by 1. If I cross multiply, x times 16 is going to be, whoa, I accidentally double tapped my finger, which does that, I guess. I have 16x on the left, and you know that 1 times x plus 5 is just x plus 5, x plus 5. This is the equivalent of that diagonal rule where you're allowed to switch diagonals. This x just came up to the 16x, and this 1 just came up to the x plus 5, right? All right, so my equation is a little bit easier to solve. The x's seem to be on the right-hand side, so you, sir, need to be over there, or madame, I don't know the gender of that x. Let's go ahead and subtract x, and what do we get? We get 5 on the left-hand side and 15x on the right-hand side. I don't have any more room, so I have to kind of squish it in here. I'm going to divide by 15, and you're gone, leaving me with x is equal to 5 over 15, but I can reduce that. I can divide the top and bottom here by 5, divide by 5, and I get 1 over 3 for my final, my final answer for x. X is 1/3 for number 8. Please. Yes, there it is. 1/3 for number 8. We're on to our last problem. The answer is going to be 7. Hopefully we get 7. All right, number 9. Whew, the biggest problem. Here we go. Again, they're both the same base here, so I can combine them into one logarithm. I can say this is log base 9 of, okay, it's going to be x plus 5, and that's going to be divided by, why are we doing division? Because we have subtraction on the outside. If this was multiplication, we would be doing, sorry, if this was addition, we would be doing multiplication on the inside. And then I have an x minus 4 down here, and the right-hand side is still log base 9 of 4. Nothing there changed. All right, time for exponentiation. Luckily, these are both base 9. If these were different bases, we would be in a problem. The only way I would know how to solve that is by graphing it or something weird like that. Luckily, they're the same base, so I'm going to do a base of 9 with my exponentiation and say 9 to the power of all that logarithm is equal to 9 to the power of all of that logarithm. Let's go ahead and move your equal to sign down. And a bunch of things are going to cancel, namely that 9, that log, that base 9, that 9, that log, that base 9. And here is what is left over. We have an x plus 5 over x minus 4 on the left. On the right, we have 4. All right, so again, it's kind of like cross multiplication where you think of this thing divided by 1, which means this x minus 4 can just come up here, and I'll have x plus 5 on the left-hand side and 4 times the quantity of x minus 4 on the right-hand side. It's time to distribute x, or sorry, 4 times x is 4x, and 4 times negative 4 is negative 16. On the left-hand side, it's still x plus 5. Haven't changed you. And I'm out of room, so we're going to come and move up here. What do I want to do? I have to choose a side for the x's. Let's put the x's over there, which means I'm going to subtract x. When I do that, I'm left with just a 5 on the left-hand side. On the right-hand side, I'm left with a 3x minus 16. Well, it appears that if this side is for the x's, that side must be for the constants, and it is time to add 16 to both sides. You get that 16 to the left-hand side, you are gone. 3x is still on the right-hand side, and a 21 is on the left-hand side. Finally, we're going to divide by 3, and x is equal to 7. Was the answer 7 or was it 9? It was 7. Let's go. The problem was number 9. That's why I was thinking of a number 9. Cool. That concludes the entire practice quiz 3.4 for Precalculus. Thanks for watching.